Okay, good morning everyone. Okay, so today we will continue for 4.3 transformers. Okay, so this is not actually the transformers. This is the one for for the movie one, Bumblebee, okay, Optimus Prime, right? Okay, so this is actually the transformer. Okay, so what does the transformer do? Okay, so in I think when you was in form 3, right? You already learn about transformer. Okay, you learn about step up. I'm not sure, maybe form 3 or form 2. I'm forget, but yeah, you already learn lah, right? So mean you have two types of transformer, which is step up or step down. Okay, so what is the function of the transformer actually? So the function is actually to change, right? To change the output voltage. Because like let's say, usually the voltage supplied to our home is 240 volt. Okay, but not all our electrical, appliance. Okay, they must use 240 volt. Okay, let's say when you charge your phone, right? So when you charge your phone, your handphone, it doesn't need to have 240 volt. So you need to decrease the voltage. So that's why we need to have a transformer. Okay, so this is the diagram of the transformers. Okay, so now for the first part, we are describing the working principle of simple transformer. So how does the transformer work? Okay, so I will just do a little revisions, okay, about the transformer. So what is the function of the transformer? Wait, okay, and is not function. Okay, so the function, okay, because sometimes they will ask you what is the function of the transformer. So it's actually to change the output voltage. Means when it says about change, voltage. Okay, when you say about change, it means it can be decreased. Oh my, no. It can be decreased or increased. Okay, so let's say you want to say to increase or decrease the output voltage, also can. Okay, so there are two types. Okay, so there are two types. There is first one is step up transformer. Okay, and another one is step down. Okay, so step up transformer means is to increase the voltage. Okay, it's used to increase the voltage, right? The input voltage, they say the input voltage is 20 volt. So you want to use 240 volt, right? So you need to increase the voltage by using the step up transformer. Okay, and we have a step down to decrease the voltage. Okay, and another one, I think you already learned about this formula, and S over MP is equals to VS over VP. So I'm not sure what happening here. Okay, all right. Let's say if I have let's say this is a transformer, right? Okay, and this is the okay. Okay, this is a number of turns, right? Okay, so usually the transformer must be using the alternating current, right? Remember, the transformer will not work, okay, if you use the DC current. Okay, it only work when you use the alternating current. Why? Because we need the change of the magnetic flux. So because of that, because we need to have the change of magnetic flux, okay, so we need to use the alternating current. So if you use a battery, the transformer will not working. Okay, will not working. Right. So at this part, okay, this part sometimes they put a bulb, okay, or maybe other electrical appliance, okay. So if they put a bulb there, okay, okay, so they say if you put a bulb there, right, this one will be the output, okay, and this one will be the input, okay. So mean this is the input voltage, this is the output voltage. Or sometimes they use primary and secondary, also same, okay. So in order, they say for this one, okay, in order, let's say you want to use this formula. So what is NS, what is NP, what is VS, what is VP? So NS is actually the number of turn. Number of turn, number of turn in secondary coil. Means this one. Or output. They can use these two terms, okay? So number of turns in secondary coil or output voltage, right? Okay, the number of turn. And then this one, okay, NP is a number of turn from primary, a primary coil. So this one, I mean sometimes they put input, so you know if already, if the question say input, all right, this is a primary, and they say this is output, oh okay, this one is a secondary, okay. So NP is a number of turn for primary coil, okay. VS is the output voltage for the secondary, so that's why VS, okay, or output voltage, also same, okay. VP is the voltage for primary. Okay, so what is the input voltage? So this one, the diagram that I draw is actually step up, right? So if I say this one to let's say 20 volt lah, right? And this one is let's say 120 volt. Okay, so means my VP, okay, my VP is 220 volt and my VS is 120 volt. Okay, so the number of turn, yeah, you have to calculate this one, this part. Okay, you have to calculate this part. Okay, how many turns it has. Okay, so that is basically what you learn, okay, for the transformer. So remember, transformer only can function when you use the AC current because we need to have a changing of magnetic flux there. Okay, and this one also use the electromagnetic induction principle. Okay, so sometimes they ask you what principle does the transformer use? So electromagnetic induction. Okay. So potential difference in the main power supply 240 volt. This one I already mentioned. So a mobile phone operates on the potential difference of 6 volt. So means, right, your mobile phone only needs 6 volt. But then what happen if you put 240 volt, okay, and you connected it to your phone? So your, of course lah, right? Your phone will be cannot use anymore, right? Okay, so how is possible? So how can we adjust, right? The potential difference from 240 to 6 volt. So this one, you know already, 240 to 6 volt, the value of voltage will decrease. So we have to use a step down transformer. Okay, for the step down transformer, right, the number of turn, okay, the number of turn, okay, for the primary, okay, must be higher than the output one. Okay, so they say this is let's say 100, okay, and this one is 50. Example, okay. So this is step down. Okay, so yeah, we use a transformer. Okay, so the diagram shows a handphone charger that runs on a low voltage of 6 volt, which can be connected to the household power supply of 240 volt through a transformer. What does the transformer do to the voltage supply it? So if you open your charger, right? If you open your charger, you can see there's a like board there, okay, electrical board, okay. Can see there is a like a diode, okay. Of course, this is a transformer, okay. They have a resistance here, okay. So to control the current, right? So the what does a transformer do? So of course, the transformer will step down. So this is a transformer, okay. That this is for the mobile phone, and this is for the microwave oven. So because we know microwave oven, they need a lot of heat, right? So when they need a lot of heat means 240 volt is not enough. Okay, so that's why we have a step up transformer to supply the higher voltage. Okay. Okay, this is the function of the transformer. A device which increases or decreases an alternating output by voltage based on the principle of electromagnetic induction. So the transformer, it uses the electromagnetic induction to work. Okay, just like mean, what does it mean by electromagnetic induction? Okay, when the currents, the induced current, right? So the current that produced when the magnetic fields, okay, or magnetic flux being cut by the conductor, okay, then you will produce the induced current. So they use that concept for the transformer. So this one is actually for the generally like the one, I don't know how to say in English, tempat jana kuasa elektrik. Okay, tempat jana kuasa elektrik, the one you see at the pencawang there, so they use this one. Okay, because like no, there's some place, okay, some place they need to use the high voltage, let's say for the factory, right? So for the factory, okay, so for the factory, of course, there we need the um there we need the high voltage to function. Okay. Okay, this is actually the one that I will discuss already. Mm, all right. So describe the structure. Okay. Describe the structure. Describe the structure of a simple transformer. Okay, I already explained just now, right? So this is a primary coil. Okay, you must use AC, and this is called as a primary voltage. This is a secondary coil, or we call it as a secondary voltage, and this is a soft iron core. So they must use a soft iron core. Okay, so that's a different of function, alright? Why we use iron core and soft iron core? Okay, then that one we will discuss later. Okay, this is a different. Why we use the iron core? Why we use a soft iron core? Right? So this is the function. So I just skip this one because we already discussed. Okay, and this is a symbol. You don't need to draw the transformer like this. Okay, for the symbol, it's just like this. Okay, for the step, this one is step down because you can see the number of turn here is higher than this one. Okay, and this the one that I draw just now, that one is a symbol. Okay, and there must be two lines, okay, between these um, two step up or step down transformer. Okay, there must be two lines here. Okay, so this is the symbol. All right. So to describe the operating principle of transformer. Okay, diagram shows a simple transformer. State the physics concept. So which explain how transformer works. Okay, I already discussed this one. Electromagnetic induction. Because there is need to be of course this one, yeah, they got the current, all right, the current supplied here, right, by using AC, but at this side, but then how does at this side they got the current, right? Because this side we don't connected it into any any like battery or power supply, right? So how does this one they can get the current now? So we use electromagnetic induction. So explain why alternating current is used. Okay, we learned just like I think 2 days ago, right? You see the graph, right? You see the graph for the DC current. So for the graph for DC current is like this. Okay, so mean they don't have a varying direction. It's only work in one direction. Okay, direct current. Okay, but for the AC graph, okay, for the AC graph, okay, when we AC generator, right? This is the graph for the AC generator. Means there is a change of the direction there. Okay. So the magnetic fields produced has varying magnitude and direction. Okay. And change in magnetic field will produce the induced current. So that is the one that I said just now. Change of magnetic flux or magnetic field is the same. Okay, can produce the induced current. You need to have they say a changing of magnetic flux. What does it mean by changing of magnetic flux? Okay, so whenever you cut it off, okay, when you cut it off, of course there will be a changing of the magnetic flux, right? So that one will produce the induced current. So they say they ask you why we use AC, why we don't use DC? Because DC they don't have varying in the direction. Okay, they only work in one direction only. Okay, so the changing of magnetic flux, right, it's not there. Okay, but the magnetic field when the alternating current, there has a varying magnitude and also the direction. So this can cause a induced current, right, to be produced. Okay, so this is the actually, if you study the notes that I gave, it's actually you can answer all the questions, especially the exercise. If even like we don't discuss, you can do it on your own. And I think when I try to find the answer, it's basically more of it as in the notes. So actually the note is very, very good. This one, the notes that I gave is actually from I'm not sure whether you know this school. It's a Sekolah Menengah Sains Sultan Muzaffar Shah. I think you know our first Datuk Syed Muzaffar, that goes to the, yeah, that is the school. His ex, like means he's the alumni there. So means the school is very good and the teacher is very good for the physics. That's why I choose that note because all the notes there, can be used. You just read that one. Okay, you can answer like the most, I feel like almost 80 to 90%. Okay, because I always refer to the notes also, right? Because sometimes teacher also, the effect of the mat that I eat, okay, that I use, okay, I have quite lots of memories. That's why sometimes it takes me time for me to answer some questions. Okay, I need to revise sometime, like to memorize it back. So I'm sorry for that. Okay, how to change the magnetic field direction and magnitude. Okay, so when a direct current, so how to change the magnetic field direction and magnitude? Because we need to produce the induced current. So induced current must have change of magnetic flux. So when the direct current battery is used, magnetic field is produced. Yeah, we already know. Current have a magnetic field. How do we know this has a magnetic field? We use the right hand grip rule. When the current comes into the paper, right? It comes into the paper, so it will be clockwise, right? The current, the magnetic field is clockwise. Okay, but let's say when it goes out from the paper, it should be um, anti-clockwise, right? So the polarity of the magnetic field will remain the same. Okay, so it will not change the direction. It will only like one flows in one same direction. Okay, because there's no, the current goes from positive to negative, that, right? Okay, but how to change the magnetic field in the directions and magnitude? Okay, so this is for AC and this one for DC. Okay, so we explain why we don't use DC. So this is the reason. Okay, then we use AC. So why we use AC? Then how does AC can change the magnetic fields or magnetic flux there? So when an AC current is used, right, the directions and the magnitude of the current change. The direction of a magnetic current change. So magnetic field is produced, its direction and magnitude always change. So for let's say for AC actually, okay, this is just like okay, positive, negative, right? Okay. So for AC, okay, we discuss about AC here. Okay. So the first part is, the first cycle, already lah, it must from positive to the negative. Then it will change. Positive here, negative here, so it go back in opposite way. So there's a change, right? Sometimes clockwise, sometimes anti-clockwise. So that's why we use it as a as in the sorry we use it in a transformer. Okay. So this is the one I showed you just now. Positive, right? And you can see there is a change of the pole here, right? The pole this side is south, right? But at this side it become north. Okay, and this side north and this side become south. Okay, because of the change of the direction. Okay, so that's why we use AC. Okay, so this is actually the right hand grip rule. Okay, and this is the oscilloscope, right? Maximum flux, maximum current, right? So flux is actually maximum magnetic field. Okay, and this is the maximum current that being produced. Right. We have this one, I think, in the lab. So maybe if we have time, okay, I will show you how to use it. Okay. This is the part. Okay. The questions for the section B, I think, the one that you need to explain for 4 marks. They will ask you how, or they ask you explain how the transformer work. Explain the principle of the transformer. Okay, so how is current induced in the secondary circuit? So let's understand this one first. Okay, so when an AC voltage, okay, when an AC voltage, when an AC voltage VP, what does it mean by VP? Primary voltage. Okay. So when I see voltage, primary voltage lah, of course lah, the one that supply the one I already told you, right? The side that have a AC voltage, that one must be primary voltage. Okay, the one that another part, okay, they connected it with a bulb or like any electrical appliance there, right? So that one is a secondary. So primary voltage is applied to the primary coil of the transformer. Okay, and alternating current flows through the coil. Of course, when you have the AC here, so it will flow, right? It will flow at the coil at the coil on the primary coil. Okay, so the soft iron core is magnetized. Okay, so when the current flows through the coil and the soft iron core, iron is actually a type of metal. So when the current flows through, like a solenoid, right? The solenoid, when you try, you put a number, you try to put a number, like few number of turns uh, of a wire there, right? And we have and it's a solenoid is actually a conductor, right? So it will produce a magnetic field. Okay, so that happen also to the soft iron core because it's a metal. When you flow the electric there, so they will produce the magnetic field. So magnetic field is actually is magnetized, mean yeah, it's already magnetic field lah. So the alternating current has varying magnitude and direction, right? Remember just now, right? It can change the directions, okay, and then you can see the pole also become difference, right? So there is a change in magnitude and direction of magnetic field. See, you can use both field or flux. It's the same. Okay. So of course there will change of the magnetic direction of magnetic field of. So this the one that we discuss now is actually you can use it to answer the 4 questions if they ask you about how does the transformer work. Teacher, is only 4 marks, but this one you got only like what 1, 2, 3, 4, like 7 point. For me, yeah, I think I told you before, right? Let's say four marks mean 4 points. You can answer as many as you can, as long like you can confident. It doesn't mean like, oh, if they say only 4, then the teacher only read only 4, then the rest the teacher don't read. No, we will read all of it. Okay, so let's say maybe this point you don't get mark, but actually they want this point, but then you have. So I think I mark like one paper Sajif. Okay, I'm not sure you are here or not. Okay, but Sajif one is, yeah, they ask only 4 points only, but Sajif explain it very, very like very detailed. Okay, so there is no point that I cannot like give him full marks. Okay, so if they say 4 points, you can give 6, 7, 8. Okay, as long you are confident, all there, let it out. Okay, what you know, okay, you just put there. Okay, so there is change in the magnetic fields and direction. So soft iron core, okay, is a linkage between the primary coil and secondary coil. So maybe this one you can make a correction here. Between the primary coil and the secondary coil. So the soft iron core is actually the link. It's the link from the primary to secondary, right? Okay, so it's only a linkage. It's just connected the primary to the secondary. So it provides a varying magnitude and direction of magnetic field in the secondary coil. So mean it's like it's transfer just now it transfer the changing of the magnetic flux on the primary coil to the secondary coil. Okay. So it's like it's not transfer lah, means a linkage, means it's just provide a way lah for the changing of the magnetic flux that happen in the primary coil, okay, goes to the secondary coil. See like this, right? See, it transfer. Okay, so this causes a changing magnetic field to pass through the secondary coil. So that's why when it when you transfer the changing of magnetic flux here. So this one also we have the magnetic flux. Okay, so this one also must have a magnetic field because you transfer, right? You transfer the magnetic fields here, right? So now they have a magnetic fields and you can see there is a number of turn there. So what will happen? So then we cut the magnetic fields, right? The number of turn here, okay, the coil here, we cut the magnetic fields, okay, that transferred from the primary to the secondary. So the secondary coil, we cut the magnetic fields and it produce the induced current. So an induced current and AC secondary voltage, okay, is produced across the secondary coil. So that's how it happens. So I explain again. Okay, so we know that when the AC power supply is flow through the primary coil, okay, so there will become a magnetic flux. Okay, then we have or there we magnetize. Okay, so the soft iron core will magnetize, and the alternating current has a varying magnitude and direction. So the soft iron core is a linkage, right? So if we transfer all the magnetic fields, okay, the changing of magnetic flux there to the secondary coil, and because of the changing of magnetic fields there, the secondary coil we cut off the magnetic fields and it produce the induced current. Okay. Okay, so primary circuit, secondary circuit. AC power supply produce AC current in the primary coil. The alternating current produce magnetic fields that change in magnitude and directions. Okay, so this is actually how you want to explain. And the magnetic flux from the primary coil is linked to the secondary coil through the soft iron core. Right? And this is what happened in the secondary coil. So the changing of magnetic field induce an alternating voltage across the secondary coil. Why? Because there is the coil here that we cut the magnetic flux. So that will produce the induced current there. Okay? And this is the formula. Ns over Np over Vs over Vp is the same. Okay? So as you can see here, there is a leakage of the magnetic flux. Leakage means not all the magnetic flux. Some of it will, like go out from the coil. Okay. And laminated. Okay. Laminated means you can see there's a few layers. Because sometimes they will ask you for the question, maybe come out for the 10 marks questions. Okay, they ask you which transformer is suitable, right? Or they ask you to modify give a modification for the transformer so it can produce the step down transformer. Okay, so step down transformer means you have to know lah the secondary coil, number of secondary coil is less than the primary, and sometimes they give you a voltage, you need to use the formula to count it. Okay, so that's something we discuss later. Okay, this is a laminated means quite a layer there. You have one more than one layer here. Okay, so this one is actually to reduce the uh, leakage of the magnetic field.
The working principle of transformer.
I'm not sure you can hear this because I don't
Actually, transformer is a
see it.
machine, but it does not have any moving part.
Okay.
That is why a transformer is referred to as a static machine. A transformer has three main parts: two windings and a metallic core on which the windings are wound. Windings are in the form of coil made of a good conductor of current. The windings of a transformer play a main role in the machine. The winding coils behave as an inductor. When an alternating current is allowed to flow through any of the windings, there will be an alternating flux produced surrounding the winding. The magnitude of this flux is proportional to the magnitude of the current flowing through the winding. The direction of the flux is according to the direction of current. The direction of the current in the winding can be found out by applying right-hand grip rule. This rule states that when we grip our right hand with stretching the thumb along the axis of coil or winding and other forefingers along the direction of current in the coil, then the thumb indicates the direction of produced flux inside the coil along the axis. This flux becomes maximum in magnitude when current reaches its maxima for 1/2 cycle of the alternating current wave. The flux becomes zero when current in the coil crosses zero axis. Again, for next half cycle, the flux becomes maximum but in opposite direction when current reaches to its reverse maxima. In this way, alternating current produces continually varying flux surrounding the winding. The flux lines link the winding itself, and the flux is varying, so there will be self-induced EMF across the winding. This phenomenon is due to Faraday's laws of electromagnetic induction. This induced EMF or voltage, whatever you say, is same in magnitude and opposite in polarity of supply voltage. Supplied alternating voltage causes alternating current in the
I think we
winding,
can skip
which
this one
produces
because this one is too detailed for you. Okay. Alright. So why does the transformer not work with a DC power supply? So this one we already know because DC only give a one direction, right? Only it only can flow one direction means the magnitude and direction will not change. Okay. So when there is no change of magnetic field in the secondary, it's a secondary coil, so there will be no induced MF. Because the primary coil, this is only one way, right? It's a direct. You don't have the changing of magnetic flux direction there, right? So how can the secondary coil we have the changing of magnetic flux, right, on and direction if the primary is not having the varying of magnitude and direction. Okay, so this is the and then describe the operating system principle of the transformer. Okay, state the relationship between the number of turns in coil with voltage. Okay, the higher the number of turns in coils, the higher the voltage, of course, right? So, and S means the voltage is increased, right? You step up. Okay, write equations. Okay, this is the equations. Finish this one. Sometimes they give you, sometimes don't. Okay. So the higher the number of the higher the voltage. So this one you remember Faraday's law said what? Right? It said the magnitude of the induced current, okay, is directly proportional to the changing of the magnetic flux. Okay, so means wherever, let's say if you increase the speed, right, means the one we discussed, increase the speed means there is more magnetic flux being changed, right? Means will be cut off. So means there is more the induced current that will be produce, right? So that's the Faraday's law. Okay, and this is the formula. Compare the number of turn. Okay, bar is secondary. The higher means this one is step up, right? Of course, the secondary circuit will be brighter because the voltage increase. Compare the primary voltage. Of course, secondary one is higher. And device to step up, we call it a device to. What is the step up transformer? Is device to increase the output voltage because they mentioned there step up. Okay, so you can say it increase. But they say they just put what is a transformer? It's a device to change the output voltage or change the voltage. Okay, and this is a step down, right? So to decrease the output, and this is the diagram for the step up and step down. Okay, so compare. This one is actually we need to do the experiment, right? The higher the voltage, the brighter the bulb. Of course, state the condition for transformer to step up. Okay, so it must be you must increase the number of turn. Okay, so in order for you to increase or decrease the voltage, the number of turn, right, is actually the important one. Okay, whether you increase, if you want to become a step up voltage, you increase the secondary coil. If you want to make it if you want to make it step down, then you decrease the number of turn in the secondary coil. Okay. Right. Describe an ideal transformer. So ideal transformer is means there is no energy loss. Mean whatever the changing of magnetic flux, I just give example. 80 magnetic flux from the primary, then the secondary also we get 80. But that is very impossible because we know that of course there will be loss of energy. Okay, there will be loss of energy. Okay, even like let's say you let's say you drive a car, right? So even like you give you give the thrust engine like 1000 Newton. Okay, but you cannot get like 1000 Newton as a net force. Okay, you need to you need to what we say that we need to um and you see suddenly I forget the English word for that. You need to mengatasi. I don't know. Okay, okay. Need to nak mengatasi the friction force. To overcome. Sorry, yeah, yeah. To overcome the friction force, right? So then you can get the net force. Sorry. So 1000 Newton. They say you need to overcome your friction force is 100 Newton. So 100 or 100. 1000 minus 100 you can get 900 newtons. So that is your net force. So same as this one. Okay, there's no way that we can get, like ideal 100%. So the figure shows an electrical equipment connected to an output terminal of the transformer. So the transformer receive input power and supply the output power to electrical equipment. Therefore, electrical energy transferred from primary second to secondary. Okay, so a transformer is an operation experience a loss of energy. Okay, therefore the output power is less than the input power. Okay, this is actually the same we know already. Okay, energy it can be lost energy, but it can change to another type of energy, right? So the efficiency of the transformer. So how do we know what is the efficiency? So efficiency for the transformer is actually depends on the power that being produced. Okay, so let's say for the bulb, got let's say the power of bulb is 80 watt. Okay, but the input power, let's say the input power for the power supply, usually I think we have for the 5 watt let's say lah 120. Okay, this is just example. Okay, remember power is what, don't take the voltage. Okay, you take the power. I'm afraid later you take the voltage. Okay, the voltage, no, we take the power. Okay, so efficiency output power is 80 divided by 120, then you times 100, so you will get the efficiency there. Okay, so this is a percentage. Okay, so what is ideal transformer? Ideal transformer is a transformer that does not experience any loss of energy. Means the efficiency is 100%. Say this one 120 watt, this one also we get 120 watt. Okay, so that is the ideal transformer. So sometimes when in the question if they say okay the ideal transformer, so when they say ideal transformer, you already know alright this efficiency is 100%. This one is 80 watt, this one also will get 80 watt, right? So the relationship between the input power and output power for an ideal transformer, okay, is actually it comes from the input power. P is equals to VI. Remember we learned that one in the electricity. P is equals to VI. So input power, remember which part is the input one? Input one is actually the primary one, right? The input voltage, the one that I said. So at this side, okay, the power is VPIP. Okay, VPIP. VP means primary. IP means current primary for primary current, right? So VPIP and this one is VSIS means secondary voltage and also secondary current. Yeah, okay. So output current. Okay. So this is the formula only for the ideal transformer because we assume the input power is same as the output power. Means 80 watt. This one also got 80 watt, but that one is impossible to happen. There will be energy loss, right? Okay, but if let's say the question set us, then we know lah. Okay, VSIS. There's a lot of formula actually you need to remember. So describe the energy loss, right? So how we can prevent the energy loss? Maybe we cannot prevent it 100%, right? We cannot totally like say, oh, we can prevent it from loss, right? I mean like 80 watt, it must get 80 watt also. No, but we can reduce it, okay? And how to do it? Okay, so in real transformer, some energy is lost in the transformer, especially in the form of heat. So it's actually the same. Remember that we did the electricity experiment. Okay, you see your constant wire. If you let's say you switch on it too long, right? You didn't switch it off. Your constant wire will become hot, or sometimes the connecting wire become hot. So that's also happen in the transformer because the current flows, right? AC current flows right through the transformer. Okay, so of course there will be heat formed there. Okay, so the output power is less than the output power. Therefore, the efficiency for the transformer is less than 100%. So usually, what kind of energy that will be lost? We call it as a heat energy. Okay, next, the factors that affecting the efficiency of the transformer. Causes of energy loss. Of course, the resistance of coils. Okay, so every coil, of course, they must have a resistance. Okay, so the effect is long copper wire because they say if you want it to make it, like to make it like 120 turns, right? So mean that you will need a long copper wires, right? To for the coil, okay? So long copper wire are used. So when the long wire copper are used, you already learned for the factors that affecting the resistance. Okay, the longer the wires mean the higher the resistance. Okay, so when the current flows through the copper wires with resistance R, heating of the wires occurs. Yeah, right. So when there is a current flows, okay, there's a high resistance. Then resistance produce the heat, okay, and it will make the wire become hot, okay, and the heat energy will be released to the surrounding. Okay, then teacher, how can we reduce this one? Okay, since we cannot, of course, we need what 120 tons of copper wire. Okay, of course it's long, right? So how can we make it short? If we make it short, then we don't have enough 120. So we increase the diameter of the wire. Okay, yeah, and I saw someone answer that one. I think there's question in the exam. Um, that one thicker wire. I'm not sure which question is that. I think for the wait I'm still marking the paper. That one is wire is for. Is it? No, no, it's not for the. I think it's for the structure one. The structure one. Actually, your question is quite easy. Yeah. I'm not sure where I read it. Maybe in the objective question. Okay. So use the thicker wire because the long wire we cannot avoid it. We have to use the long wire. So you use a thicker wire. Okay. Then eddy currents. Okay. Eddy currents. So effect of energy loss. Okay. So inside the let's say okay. If you use like one layer only. Okay, I mean we use a one layer only. So around like inside the a soft iron core itself, okay, then we have the current flows. So this one is like twisting the currents. Okay, so we make it as a thin sheets of soft iron. Okay, so and we make it thinly laminated. Okay, so this is because the to reduce the eddy current. Okay, I mean for this one is quite thin, right? So even like eddy current form is not that much. If you use like this one block like that, okay, then we use a layer or the laminated one. Okay, so use a laminated. Okay, this question, this one factors. Okay, the factors is actually you use it for transformer questions for number for the 10 marks one. Then we ask you how to reduce, then how to modify, produce the transformer, beta transformer. So you need to know, you need to write all this. Okay, use a laminated iron core. Why? To reduce eddy currents. So that's why I said the note is very good actually. So this one is for to help you to answer section B or section C. Okay, so use laminated iron core that consists of thin iron sheet glued together with insulation glue. Okay, means is for insulation glue means the current can still flow. Okay, because insulation, right? Okay, then the next part is, oh sorry, hysteresis. Okay, the loss of energy due to the magnetizing and demagnetizing the core by the alternating current in the primary core. This produce heat energy. Alright, for soft iron core, okay, for soft iron core, right, there will be like, this sometime when the current flows, it will be magnetized. Then when it stop flow, because the graph is like this, right? Yeah. So means sometimes there will be current flow, sometimes there will be no current flows, right? So this one, this the loss of energy due to the magnetizing and demagnetizing the core, alright? So the alternate, it will produce the heat energy. Okay. Sometimes there's current, there's no current. This one, okay, the current maximum. Then this is no current again, right? So how to reduce the loss, energy loss? Okay. So we use a soft iron core. Soft iron core to easy to magnetize and demagnetize. This one is for the AC part. They say, what the for the 10 marks one. Okay, whether section B or section C. Okay, if they ask you about transformer, okay, which one you want to use? Whether you want to use soft iron core, okay, or you use a soft cuprum, okay, let's say. So use soft iron core. Reason easy to magnetize and demagnetize. Okay, so that's the reason. Alright, the next part, flux leakage. Okay, alright, flux leakage. This one I already explained, right? Okay, not all the magnetic field will flows through the transformer. Some of it will come outside of it, outside from the transformer. So there, of course, there will be a leakage. Okay, does not pass through the secondary core. So this will reduce the EMF. Okay, so that reduce the EMF. So means the current or the power, the voltage that we produce in the secondary core also will be less because there is a leakage, okay, of the EMF there. So how to reduce energy loss? the secondary coil is wound on the primary coil. So means they have to be wound on top of it. Okay, if they say it's like on top of it. Okay, so all that the magnetic flux produced by the primary current will pass through the secondary coil. So see this one? Yeah, right? Not like on the left, on the right. Yeah, I know. Okay, teacher, in the diagram we draw like this, right? One left, one right. Okay, but that is actually as a symbol. But this one is actually you need to wind it up on the secondary in the primary coil. Okay, so you need to secondary coil is wound on the primary coil. So this is the diagram. Okay. Okay, so we just talked just now about how bad is eddy current, right? Okay, but sometimes eddy current is also very useful, especially for the induction cooker. Okay, so this is the example lah. How does the eddy current is actually functioning, okay, in our life. Okay, so the high frequency alternate AC current, okay, in the coil producing a magnetic field that change in with a high frequency. So this magnetic field induce eddy currents at the base of the bands. Okay, so the eddy current here, right? So then it, of course lah, when the eddy current produce, then we have a heat, okay, from it. Okay, all right. So this one essentially applications. Okay, so step up. I think you already know this come from the power station. Okay, so when the goes to the power transmission cable, yeah, this one is important. Okay, power station. Okay, power station. Okay, we transfer the voltage, right, to the transmission. So you have to use step up. Why you have to use step up? Because transmission cable, you know, it's have a long wire, right? Long wire. Okay, and you know, so means that we have a high resistance. So when high resistance means you will lose a lot of energy there because you need to overcome the resistance. So that's why we use a step up, okay, at the transmission cable. So it can reduce the energy loss there. Okay. Then it goes to step up again. Okay. Sorry, step down because now we have to send it to the consumer, right? So we need to have a step down. Okay, we cannot send they say this one until 1000 kilovolt, right? Then we cannot send 1000 kilovolt to our house lah. So of course you need to have a step down. Okay, then it can go to our house. Okay, so remember this one. Sometimes they ask you to fill up which one is step up, which one is step down. Okay. Okay, this is actually the transmission of the electricity. I don't need to remember the all the voltage. What you need to do is you have to know which one have to be step up and step down. Okay, this one step up, of course. And so this one go back, step down, step down. Okay, step down. Okay, light industry, step down. Okay, step down. We have to see the voltage here. So if the voltage decrease, so step down. Only one part is step up. Okay, that is because of this one. The cable is quite long. So means the resistance is high. So we need to cover the loss of energy. Okay, so this one is the example. So I just discussed this example. I think this is on your textbook, right? So basically, you just use the formula. Remember for the power, output power, and then they say, okay, right? The transformer is ideal, which means 100%. Okay, VSIS equals to VPIP. Okay, when they say about the transformer is ideal, VSIS equals to VPIP. Okay, calculate the number of turns in the on of the primary coil. So we just use that this formula VSNS because they ask you to find the number of turn, right? If you use VSIS, VPIP, there's no number of turn there. So we just use this one. Okay, then you can get the answer. Then for the current in the secondary circuit, okay, so VSIS, VPIP. okay, and the current in the primary circuit, okay, we can use this one because we already know the the current in the secondary circuit. So of course we can know the current in the primary circuit, okay, by using this formula. All the info is already given, but remember, okay, power, okay, don't use a voltage for the efficiency. Okay, so the rest maybe you can try it, okay, on the on the at your home, okay. Then later maybe I will go like 10 minutes to answer for this question tomorrow, okay. Then we go, I think we 4.3 we already finished. Yeah, chapter 4 we already finished. Now we are going to chapter 5, okay. So chapter 5, and I think I want to do a revision, but at night. Okay, is I don't like, I know like some of you got tuition, like class every night at night, okay. Like got homework or whatever. But I will just do, whoever can come, you can come, because I will discuss. Okay, I will discuss the questions, the SPM one. Okay. Last year, right? And also the trial for the negeri one. I will, divide by topic first, then that one I give you answer, but I will also discuss. Okay, I will also discuss. So, after I finish all the chapters, okay, so at night, I will tell you when. Okay, maybe is every day or what, or at school pun kita akan buat ulang kaji juga kalau ada masa, sebab you will be busy after this. We will do this. So I will record. Okay. So please, like if you can attend, please attend. Okay, because I see your paper. I mean, like I'm quite worried. Okay. So I see you tomorrow, right, for chapter 5. Okay. So thank you everyone for come to my class today. Right. So if you see you tomorrow, okay, take care everyone. Bye. Yes, yeah, 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 yes, yes, yes. Wait. Any questions? Oh, bye bye. Bye. Eh, don't forget nak give me the... Alamak, lupa lah nak cakap. Janet. Janet already come on. Yilim. Tell me how many people can attend 25 after Christmas, the week. And also 5M. Yeah, we can. Ask them how many of them can come during like after 25. I 25 no lah, I mean like 26, 27. Okay? Uh For now, 13 people respond me. Okay, let me give you time until like this Friday. I think tomorrow. Okay, tomorrow. Because I will do the class. Right. So thank you everyone. Bye. Oh, so far about 4 cannot attend. Okay, never mind. I just do 4. Okay, bye. Okay, take care weekend.